In today's class, we will talk Dijkstra's algorithm. So this algorithm is used to find shortest path from a particular node to the all the other nodes in the graph. That is, if you look at this example, if you give this graph as an input to the algorithm, Dijkstra's algorithm, and you say that A is the source node, your Dijkstra's algorithm will be finding shortest path from A to C, A to D, A to B, A to E, A to F, and A to F, and A to G. So from a source node, it will be finding all these shortest paths to all the other nodes. Okay. So where do we use it? Usually it is used in applications like Google Maps, where you would like to find the shortest path from your present location to a destination. Okay. So for such kind of applications, this algorithm is used. So let us see how this algorithm works. Here initially, we start from, let us assume we start from the node called A and we call it as a source node. Cost of reaching A is 0 because this is where we start, and cost of reaching all the other nodes, okay, from A to all the other nodes is infinity, because till now we have not explored it and we don't know what is the cost associated with it. So we start from A. Once we are at this point, I mark this node as visited. Okay. Then what are the nodes which I can see from this node, what I explore from this node? One is I have a edge from A to B, and also I have an edge from A to D. Okay. So now I update the values in such a way. So cost of reaching A to B, cost of reaching B via A is 2, which is less than infinity, so I update it. Cost of reaching D via A is 1, which is less than infinity, so 1 gets updated here. So I'll be having an arrow up in this way for both the nodes to indicate that the parent of B is A and parent of D is also A. That is, I have come to this point via node called A, and also I can reach D via node called A, and the cost associated here 1 is from distance from A to D. Okay, so this is what we do. Okay, and that is what we have shown here. So arrow implies that the parent of B is A, that is previous node was A, and this also implies that the previous node was for D was A. Now similar to a Prim's algorithm, what do we do is we find the minimum distance or minimum cost node here. Here the minimum cost node which we have is D, which is 1. Okay, and the same process will be repeated. So from D, what are the nodes which we can now we select this part, we select this node and we make it as visited. From D, what are the nodes which we can visit? So we can visit C. Okay, so I make an arrow in this way, that is parent of C is D. I can visit F, I can visit G, and similarly I can visit E. Okay, now let us see how do I calculate the costs of all the other nodes now. So cost of, now here let us see for calculating the cost of E. Cost of reaching E is nothing but cost of reaching D to E plus cost of reaching D. So I also consider the previous cost, that is cost of reaching D to E is 2 plus what is the cost of reaching D? 1, which is 3. So total cost of reaching E is 3, which is less than infinity. 3 gets updated, and this arrow here indicates that the parent of E is D, that is I have reached E via D. The same thing will be done here. So cost of reaching D is nothing but cost of reaching D to G plus cost of reaching D. So cost of reaching D is 1, okay, plus D to G is 4, so 1 plus 4 is 5, so 5 will be here. Cost of reaching F is D to F is 8, 2D, that is still cost of reaching D is 1, 1 plus 8 is 9, 9 is less than infinity, 9 gets updated. So the same thing here, the cost of reaching C is nothing but cost of reaching D plus cost of reaching D to C. Cost of reaching D is 1 plus D to C is 2, 2 plus 1 is 3, less than infinity, so 3 gets updated here. So here this arrow indicates the parent of C is D, and I have calculated it, calculated the cost of reaching here as cost of reaching C to D plus cost of reaching D. So this is how I calculate the nodes. Okay, so this is what we have done. We have updated the values. Now two nodes are visited for us, that is A and D are visited. Now let us look at what are the nodes which we have 2, 3, 5, 9 and 3. Out of this, again the same process, that is we have to select the minimum cost node. Okay, so the minimum cost node which we have here is B, so I mark B as visited. Okay, so what is the parent node for B? A. This line indicates that previously the cost of reaching B is 2, that is via A. Okay, next from here, what are the nodes which I can explore? B to D. D is already visited, so I don't visit the already visited nodes, so this is out of question for us. The only node which I have is B to E. So from B to E, for cost of reaching E via B, let us calculate what is the value. So cost of reaching E is nothing but cost of reaching B to E plus cost of reaching B. So B to E cost is 10 plus cost of reaching B is 2, which is 12. What is the value which we have here? 3. So 12 is not less than 3. I don't update the values here. Okay, if and only if the new cost is less, then only update. What does it imply? Previously I was able to reach E via D with the cost of 3, but now if I want to reach E via B, what is the cost which I have to incur? 12. So which one is better path for me? Previous one was better, that is via D is better for me, so I don't update it. Okay, and there are no more updations in this step for us. Okay, so that is what we have also written here. Okay, now with no updations, B is also visited. These 3 nodes are visited for us. Now we have E, G, F and C, so we have to select the minimum node, so minimum cost node. So here C and E are having same cost, so it doesn't matter which one you choose. So for our simplicity, for our purpose, we'll be selecting E, so E gets visited. So what is the parent node of D? E, which is D for us. So let us see from E what are the nodes which can visit. There is only one edge which comes out of E, which is to G. Okay, so what is the previous cost of visiting G? 5 via D. Now let us see how do we calculate cost of reaching G here. Okay, so cost of reaching G via E is nothing but cost of reaching G to E, that is E to G plus cost of reaching E. E to G cost is 6 plus cost of reaching E is 3, which is 9. 9 is less than 5? No, 9 is not less than 5. So what happens? It doesn't get updated. What does it imply? So previously cost of reaching G was 5 via D, but cost of reaching G via E takes me 9. So I prefer the previous path, which is via G. So this does not get updated, and there are no more updations here. Okay, so this gets visited. There is no updation for us. Next we have 3 nodes which are left out for us. Out of these 3, C has the minimum cost associated with this, so I select the, what is the parent node for C? D here. Okay, so from C, what are the nodes which I can visit? C to A. A is already visited for me. Next I have C to F. Okay, this is only one edge which I have coming out of C. So cost of C to F. Okay, let us calculate. So cost of reaching F via C, so this is via C, is cost of reaching C plus cost of reaching C to F. Cost of reaching C is 3 plus cost of reaching C to F is 5, which is 8. 8 is less than 9, so what do I do is this gets updated. This arrow is removed for us, that is previously cost of reaching F was via D, which was 9. Now I update it to 8, and what is the parent node now which I have? C. Okay, so this arrow gets removed, so F can be visited via C here. Okay, next I have 2 nodes which are left out. Out of this, 5 is the minimum cost node, and what is the edge which I have? Only one edge which I have coming out of G, so that is reaching F. So cost of reaching F is nothing but cost of reaching G plus cost of reaching G to F. Cost of reaching G is 5 plus cost of reaching G to F is 1, which is 6 for us. Okay, so 5 plus 1, 6. 6 is less than 8, condition satisfies. So what do I do is, previously the cost of reaching F was 8, that is was which was via C, so I remove it. Now I have found a new path for it, that is I say that via G it takes only 6, that is 5 plus 1 takes only 6 cost. So what will happen is this will be updated, okay, and this will be 6 for me. So only node which I have left is F. From F I don't have any edge coming out of it, so I stop it. Okay, so this is the minimum single source shortest path for me. That is, for example, if I want to reach G, how do I reach it? So G to D and D to A is the shortest path for me. Okay, from all the other nodes I can reach A via, these are the shortest paths for me, and also from A I can reach all the other nodes I am using the shortest path. So from F, if I want to reach A, so first I have to reach F to G, which is 1, G to D, which is 4, D to A, that is 1 plus 4 is 5, 5 plus 1 is 6 for me. Okay, similarly if I want to reach E, so A to D and D to E, so which is 3 for me. Okay, so from single source I can reach all the other nodes using this algorithm. Let us take another example here. In this example, so the same A is the source node for us. From A, what are the nodes which I can explore? So the nodes which I can explore are B and C, and that is why it gets updated. Okay, so 10 is less than infinity, so 10 gets updated here. 3 is less than infinity, so 3 gets updated here. Okay, next, out of these two, which one is minimum for us? 3 is minimum. So from 3, what are the edges which we have? C to D and C to E, and also C to B. Okay, so first let us calculate this edge. So cost of reaching B via C is cost of reaching C, which is 3, plus C to B, which is 4, which is equals to 7. 7 is less than 10, condition satisfies, so this gets updated by 7, and the parent node for it is C for me. Okay, then this implies that cost of reaching this is 7 via C. Now let us look at another edge, so C to D. So cost of reaching C is 3, plus cost of reaching C to D is 8. 8 plus 3 is 11 for me, which is less than infinity. So 11 gets updated here via C. Another edge which I have is E. So cost of reaching C is 3, plus cost of reaching C to E is 2, which is 5. Okay, 5 is less than infinity. So here what will happen is this gets updated to 5 via C. Okay, so this is what we have obtained. Okay, so 11, 5 and 11 and 5 and 7 gets updated here. Okay, so previously it was 10, it gets overwritten with 7, and 11 and 5 are obtained for us. Out of these 3, which one? So A and C are visited for me. So 7, 11 and 5, which one is the smallest cost associated node? So 5 is the less cost associated node. So I select E. From E, what are the nodes which I have? E to D. Okay, so only one node is available to me. So from E to D, let us see what is the cost. Cost of reaching E is 5, plus cost of reaching E to D is 9, which is 14. 14 is not less than 11, so I stop here. I don't update anything. Okay, so I don't update it at all. So now we are left out with two nodes, 7 and 11. Out of the 7 is the smallest cost associated node, and I have two edges coming out of it. One goes to C, which is already visited, so I don't do anything. Then I have one edge coming to D, so this is not visited. So cost of reaching D via B is cost of reaching B, which is 7, plus cost of reaching B to D is 2, which is 9. 9 is less than 11, condition satisfies. So here I change it to 9 via B. Okay, so this is the minimum cost 3 which I have. So these are the examples which we can go through for our example purposes.